Yes, dear student, and we will continue last class where we have seen that how we can use Matlab software for optimize a problem. Yesterday we have seen a simple that means problem. Today we will see some more problem so that you can that means understand in better way different kinds of problem how to handle with this software. Yesterday we did it only linear type of constants, if you remember that, and now this is when we have non-linear constant. Okay, if you see, we have we already we discussed this problem. So today we will see first just a recap. If we have a number of constant here, right? G1, G2, G3, these are the constant, and earlier question only we had one constant. Then we have seen the things here, how that means how the things, that means how we can get the that means best result using by that means graphical approach, using by code if I am writing Matlab code, and using by that means optimization tool. Let's do again, I will do the same problem. Now the problem here is, first is we have an objective function, and that we need to minimize it, right? Remember, we need to minimize it, and only two variable we have, x1 and x2, and minimum minimize function, that is 3x1 and 6x2, and subjected to, that is a g1, g2 and g3. It is given, and here x1 and x2 are greater than 0, that is the things here it is given. If you see g1, that is less than, that is the function, it is less than 2, g2 also less than, if you see that this is less than, but here it is a greater than. So then that means you have to make it is a less than, so that you can easily solve, and you can see it. So you can keep everything in the same way, that is a less than. So let's do the first with the help of this code. So already I have written here. If you see that the code is here, yeah, this code is here. X1 x2 the same as the last one, and right now we have a function, that is objective function, which is 3. This is the objective function, I can write here so that you can understand objective function. Check objective, and need to minimize it, need to be minimized, right? Now we have a inequality function, that means subjected to what? The first is here, if you see that we have, this is the inequality function, the first, that means subject, that is a constant of the first constant, and this is here minus 3x1 plus 3x2, which is less than equal to 2. So first of all you need to define in this form. If you see that already I have defined that inequality, these things, right? And these are the code, you can see, these are the things. And now the next is, it is saying that this is the function, that is 4x1 plus 2x2, which is less than equal to 4, right? So now the code here, it is says this one, the second meaning, right? And this is less than and equal to 4. Remember. The third one, if you see that here, that is minus x1 plus 3x2, which is greater than and equal to 1. So we have to make it this is less than equal to 1. But how? If I am multiplying by minus negative sign, that will be that things will be changing what we want. So that will be the plus x1 minus 3x2 less than equal to minus 1. This will be the things here. That's right. Now if you see that, you will be getting third constant, that this is the third one. You can see x1 minus 3 x2, and that is equal to, if you see that, minus 1 minus 2, right? All these things I have written here, you can see it. Again I am going from up. This is your objective function, right? This is the limit from 0 to 5. You can play with this limit, right? First you need to find out the feasible region. So let's run it. So now if I run it, so this function itself, it is showing the first function, so that is a g1. So that g1 will be, you can see here, the g1 I have that this is the things here which is less than 2. This is your g1. Yeah, this is your g1, so I can put here name g1, right? Now this is your g2, and so that means the domain, if you see for a red one, that means g1, this is feasible for this one, right? The domain for this one, this is feasible for this one, and domain for last one, that means g3, that this one will be the domain. So where will be the mean, that means what will be the feasible, this will be the feasible region. The whole domain, if you see that, this is the feasible region. In this feasible region, what will be the minimum function? If you see that, these are the function, you can see that the minimum is occurring here at here, that means 0 and some value. I don't know that value, you have to see it with the help of that means software. Yes, you can find out what will be the value when it is a 0. So what will be the value? If you find it, you will be getting 0.333. We will see it also, these things. So the value here will be 0 and it is showing it is 2. So this will be the minimum value, right? I just you can see it, this will be the minimum value. I can just, I took it, that's, I can, yeah, zoom it. Let's see, I can zoom it. So you can see this will be the minimum value here, right? This will be the minimum value, okay, with the help of graphical, and this will be the, this whole will be the uh, domain, that means the feasible region. This is the feasible. So let's do it again. If I want to change the color of this line, the first one was the red, second was the blue, and this was the, I can make it here, this will be the green, GR right? So let's run it again. So this is by default g1, it is coming. This is g2, and this is your g3, and this is green, it is coming. Let's see again, I have to see it, why it is not, where I should change, ah, here the set, I have to change it here, green, g, right? Yeah. So let's run it again. g1, this is g2, this is your g3, right? And the feasible region will be this. So this is also, it is showing g. I can change this one is with magenta, m I can write it magenta, yellow also I can write it, black also k, that all the things it is written in the, that means Matlab help. You can get the how we can change the color of line and all these things. Yeah, we can do it, all the things. Again I am doing g1, this is g2, and this is g3, and this is your feasible. So now if you see that, if you see that, oh, if you see that I have the function, that is minimi function, the value 0.5, 1, 1.5. So I can extend till here and up to that mark. So let's see, let's do it from where I can change it. Yeah, from here, if you see that I can change these things. uh, Let me see one more time. That will 0.5. Where is 0.5? Yeah, here is 0.5. So I can change it here till 8. Let's see. So now you can see I am running here the first. Oh, I'm sorry, I must keep here G1 and G2, G3. As you can see here, now again I am running it. Yeah, this will be the G1, right? This will be G2, this will be G3, and you can see already. And this is the minimum if I say, and what will be the maximum if I say that this will be the maximum, right? This will be the minimum where it is 2, it is giving a maximum will be at 8. This will you can get maximum value from the graphical method. It is very easy for you. If you look the graph, you can easily find out. So this will be the minima, right? And this will be the maxima, you can find out, right? So with the help of graph you can find out easily. But if I ask you in this problem, you find out minima, so what you will do it, you simply change it by negative sign, so you can get it maxima there. Similarly for here, if I say this is the minima, if I want to maximize this function, so I can put here negative negative. So it will give you the maximum value by changing its things here. Now the next, how we can find out this function by coding. So let's see. I have, this is my objective function. So the starting point here I can take in a feasible region. Always try to make it in a feasible, otherwise it will sometime it will difficult when non-linear equation will be there. But right now it is a linear, it will not tough. So but I would say that you can take it always in a safe zone. So lower will be this value, upper will be 10 10. So I can take here 5 and 5. Okay, the most important part here, if you see that a and b, so what will be a here? If you see that this function, the a here is if you see that the coefficient of x1 and x2, so that is a minus 3 3 4 2, here plus 1 and minus 3. So you can see here the coefficient here is the same way, right? And this is the vector, that is the right side vector, that is this one, 2 4 and minus 1. I put here 2 4 and minus 1, 2 4 and minus 1. I don't have any equality, that is this one, we don't have equality 1, and also we don't have any non-linear thing. So let's run these things. What will be the exact value? From here you can get the exact value, but from the graphical it is very difficult to find out the exact. Yeah, you can judge it from the graphical. Yeah, this will be the point or location around things. You can say that this will, here will be the minima or maximum will occur. Let's run it. Yeah, I run it. Now you can see this is the point, that means x1 and x2, and the value will be 2. You can see the result here, the value is here 2, it is telling you, right? By this function you can write, you need to change it, the function, that is inbuilt function f mini con, f min con. If you can use it, you can think that. So already I have these things, I will circulate it, how we can use this function and all these things. It is written here, all these things, right? So I will circulate it to you so that you can understand in a better way. Okay, now if I say you need to find the solution using by optimization tool, likewise last class I did it. So let's see, you need to write here OPTM tool. It will be immediately, it will go to the here. Already I have fitted here. The first of all you need to write here the function. If you see that already I have written here the function. This is your function, right? You need to write it this function, and this is your function, right? And this will be display, it will be the function here is this thing. Only you need to recall this function, and here we don't have any non-linear, so no need to recall non-linear constant. So only we have a function. Once here, once here we write a function, and see a starting point. I am saying whatever I have taken for this the last problem, this one, the starting was 20, so I can keep it here 20, 2 and 0, right? And you can see here a whatever I told that you have to keep it here the function. If you see here, yeah, this is the function. You can see -3 plus 2 4 2, you can see here, and here you need to multiply with negative as 1 and -3, and then this will be the b. This is 2 4 and -1, and equality we don't have any equality, so no need to write it, no need to write it. And lower will be value, this will be the upper. I am taking that x1 and x2. We don't have any nonlinear constant. Let's run it. First of all, clear all the things. Let's run it. Now I am running it. You can see, yeah, so initially once you are putting this value 2 and 0, it is giving this one, then it is suddenly decreasing, and that things it is, I can say after 3 iteration it is almost flat, or I can say it is converging. Once it is a converging, then we can say that is the best result. You can see here, this is the things here, constant violence. The first will be the constant violence, it is saying that the another will be, it is not saying any constant violence, right? You can see here the value, it is a 0 and another value 1/3. So you can see here 0 and 1/3, it is telling you, right? This is the value, and you can see local, you can read here the local minimum found that satisfies the constants. That is the most important part here. And now you can see overall result. Yeah, after 6 iteration you are getting the answer. So you can think about, earlier we had these things, when I was using this optimization tool, I am getting the same answer, right? This is the things here, iteration, f count, function value. You can see the function value here is the function value. So you can that means uh, make your accuracy, that is more. So you can substitute here, the accuracy must be, what should be accuracy, a stopping criteria, iteration, x tolerance, the function tolerance, the constants tolerance. So all these are given, you can use it, you can supply here, and you can get the best result, right? So I did not write anything, that means it is a by default. You can see that it is a minimum, you can see 10 to the power -6, that is very small. So that means it is the best answer. Okay, so by this way we can get the result, right? Once again I should say, yeah, right, after 6 you can see here the things are here, yeah, here. Now again I can put here all clear, cl clear all, so that all history will go on, right? So let's run once again the same problem, clear everything. Now start. Yeah, 2 That means x1 will be this 0, x2 will be 1 by 3, that is, and you can see here that the same answer it is giving you, and you can see the result after how much the whole history of this function, that is f minicon, it is given here. The objective function, the name is gradient Hessian. Hessian already I told that. What is Hessian and all these things. A number of inequality considered. Yes, I had three. Here, this is zero. The lower upper boundary. All these are given here. You can see the history, and this is the iteration. This is a f count. This is the feasible value, that is function value, feasibility. Okay, and the and no norm of optimity and steps and all these things, right? So you can read about all these things. Let's do for third, that is last problem what I am interested. You can read this problem and you can see the difference between these two. That means last problem and this problem. And if you see, we have a non-linear constant G1, you can see here G2 and H2, and along with we have a equality one, right? So let's do this problem, how we can do this type of problem using Matlab. So already I have written its code here, so that writing the code it will not take much more time. Yeah, you can see the function I have this one, that means x1 minus 3 whole square, x2 minus 2 whole square. That is the equation of, if you see that the circle, right? This is equation 1. Here you can see it. This is your equation, and g1 and g1 you will be having the equalities first g1, this is the, and it is a 7, right? So I wrote here. The next will be g2. So g2 is here, if you see the inequality, so that means g2 will be here. Yeah, this is the inequality, right? But this is non-linear, if you see that. The similarly for h1, right? Similarly for h2, right? And function. Let's run this problem, run this code. First of all, we need to clear everything here from the history and the command window. Let's run this. Now I'm running. Okay, I should. Okay, let's run it. So this is the, if you see that this is the G1, this is the linear one. If you see it, this is the G1, right? This is G1, and which is less than equal to 7. That means the feasible region for these things is this side. Now next will be the G2. So let's see, this is, I am keeping name G1. You can see this is your G2. If you see that G2 is this one, this is the G2, and which is less than, that means the feasible region is this. Now the next will be, this is, I am keeping this one. Next will be this H1. So this is your line. That means solution must be lies on this line. That is the most important part here. Solution must be lies on this line. The next will be this. This is your H1. The next will be this, right? This is your H2. I can keep here name H2. Yeah. So I have, this is the function, you can see it here. So where will be the minimum, that means minima, you can see the solution must be lies here, and on H2 and H2. So what will be the feasible region? So this will be the less than, this will be the feasible region will be these things. You can see it, and must be like that means this is the minima is taking. This is the minima taking. Yeah.